I'm going to begin with the last question of this exercise 8.4, that is asked to prove that these two results are same as the RHS equal to tan square. So now I'll start with 1 plus tan square A by 1 plus cot square A. So this one is nothing but using identity. I'll write the identities again here. So I use a better color. So now I'll write the identities for convenience. So 1 plus tan square A is equal to secant square A, and 1 plus cot square A is equal to cosecant square A, and sine square A plus cos square A is equal to 1. These are the three identities. This is universal. This is valid for all angles, but these are valid only when the angle is between 0 to 90 degree. So this is for all angles, all A values. So now I'm going to start now. So if I use the identity, then this is nothing but secant square A by cosecant square A. Similarly, I know that this question already we solved in the exercise before, so this was nothing new here. So if I take cosec square up, then it will become sine square A. Similarly, I bring this down to denominator, then it will become cos square A. As you know, as I hope by now you might be familiar that 1 by cosecant square A is equal to sine square A, and secant square A is equal to 1 by cos square A. So now I will continue. So this is nothing but tan square A. The first part was simpler. Now coming to this one, 1 minus tan A by 1 minus cot A whole square. So I will first start by expanding, as I said that we have to, when tan is there, you have to start by expanding. Most of the cases it will work, but there are cases we saw sometimes it is not working. 1 minus sine A by cos A divided by 1 minus cos A by sine A whole square. So this is what is the expression, whole square. So now if I start taking LCM, so it will be cos A minus sine A by cos A whole square, which I can directly write it as, I will split this and write for the convenience. The numerator and denominator I will write separately. Square by, I can write this as directly cos square A. So into, again sorry, it should be, okay, into I can write as denominator will come up, denominator part, again this form of A by B, C by D. So if I divide, as I mentioned earlier, mentioned so many times already, this is of form AB CD. So this part I can write A by B divided by C by D. Yeah, many people know this, but there is often a confusion exists. So I can write a by b into b by c. This part is nothing but denominator, and this is numerator fraction. So I will reverse the denominator and multiply with the numerator. So this is what I am doing here. So if I take LCM, it will become sine a minus cos a, sine a minus cos a whole square. Now you can I can like terms, I can not like terms, I can separate the terms for convenience. I will interchange sine square a and this cos a minus sine a whole square. As you can see that we have already got tan square a, so this is nothing but tan square a, but I am continuing it into cos a minus sine a whole square divided by now I want to take minus sign common here. Minus of, if I in the new denominator, if I take minus sign common, it will become minus of cos a minus sine a whole square. As you know that minus 1 square, again I am stating it, minus 1 square is 1 itself. So minus 1 square is equal to 1 itself. So I can write this as, I can simply write this as tan square a. So this part tan square a, this part I'll write tan square a into cos a minus sine a whole square divided by, so this minus 1, I can write minus sign is nothing but minus 1, I will taking minus 1 outside. So minus 1 square is 1, so I can write directly 1 into something is the same number, 1 into x is x. So you don't need this one, everyone knows it, but for the sake of it I am just reiterating it. So whole square. So this is nothing but these both terms are same, so I can cancel them out. So the remaining will be tan square a, which is equal to RHS. So with this the exercise 8.4 is completed, and I will bring if possible I will explain one example problem which is there, and also I will try to bring a few more practice questions if possible. Thank you.